Sure. Write some points within this one. Keep a note. Interference follows the law of conservation of your energy weight. First point. Interference follows law of conservation of energy. That is, energy can neither be created nor be destroyed, but it can be converted from one form to your another form. In the same way, if I need to calculate average intensity, you can calculate average intensity by the formula I max plus I minima divided by, okay, and I1 plus I2 will be equal to your A1 square plus A2 square. So average intensity is equals to I max plus I minima divided by 2, and I1 plus I2 will be equal to A1 plus A1 square plus A2 square. And one more very important point is intensity is directly proportional to width of slit. Obviously, the slit is just some than, and it is directly proportional to square of your amplitude none. Square of your amplitude. Second, right? Intensity is directly proportional to width, and it is directly proportional to your A square. Very important. Chanasal problems which are in final. So I can write here, if I'm taking the ratio, I1 by I2 is equals to width W1 divided by width W2. That is equals to A1 square divided by A2 square. Clear? So this is one important formula you need to remember. Clear? Sure. And one more important one. What is the ratio of your I max and I minima? That is known as of your fringe visibility value. I max divided by I minima will be equal to, this is root 1 plus root of your I2 whole square divided by root of your I1 minus root of your I2 whole square. Okay, root of your A1 will be equal to how much better? This is your A1 plus A2 whole square divided by A1 minus of your A2 whole square. Okay, that means it is directly proportional to your A max whole square divided by A minima whole square. So these formulas are also very important. I max by I minima is equals to root of your I1 plus root of I2 whole square divided by your I1 minus of your I2. Okay, na? Sure. And one more important term, we call it as of your what? Fringe visibility. Fringe visibility. What do you mean by fringe visibility, beta? Fringe visibility is nothing but fringe visibility is represented by V. V is equals to I max minus I minima divided by your I max plus I minima multiplied by your 100. Okay. If I minima is 0, then fringe visibility is maximum beta. That is when both the slits are of equal size, the fringe visibility is best and it is equal to how much for me? 100%. Clear? I'll write that point here. When I minima 0 in అనుకోండి, I minima 0 అయితే right now fringe visibility ఎంత అవుతుందండి? Maximum. Then fringe visibility is maximum 100% అవుతుంది. That is when both the slits are when both slits are of equal width or of your equal width and the fringe visibility is best and is equal to 100%. Okay, so it is one important formula you need to remember. Fringe visibility is I max minus I minima divided by I max plus I minima into your 100. Clear? And let us try to define two more terms here. మీరు already IPలో చదివింటారు. One is known as of your coherent source. Another one is known as of your non-coherent source. Non-coherent source. What do you mean by coherent source, beta? And what do you mean by non-coherent source? Coherent source అంటే phase difference is constant. Phase difference ఎంత? Phase difference is constant. ఇక్కడ phase difference is not constant. Phase difference is not constant. Okay, and this one, frequency of the both sources is same. Frequency of both source is same. If the frequency of the both sources is same, that will be called as of your coherent. Whereas here, frequency are not same, you can write. Okay, and it shows the phenomenon of interference. Example for coherent source is interference, and it do not show no interference in this. Clear? Phase difference is how much for this one? Constant for coherent. And frequency of the both the sources is also same. Interference can be seen in this one. Whereas in the non-coherent, phase difference is not constant. And frequencies are also not constant. They are called as of your non-coherent sources. Clear for me? Sure. One important formula, beta. The resultant intensity is also given by the formula I resultant is equals to 4 times of I naught into cos square 5 divided by 2. ఈ ఫార్ములా పైన కూడా చాలా సార్లు ప్రాబ్లమ్స్ అడుగుతుంటాడు. Okay, like say when two waves of intensities having the same frequency and same amplitude or interfere, then what is the resultant intensity అని అనుకుంటా. అప్పుడు ఏమైపోతుంది right now for me? If phase difference is zero, like say for example, if phase difference is zero, phi is equals to zero. So phi is equals to zero, what will be the resultant intensity beta? So it is cos square, this value is totally zero, 180 divided by 2 is 90, or 0 divided by 2 is nothing but 0. Cos 0 is right now for me cos square theta. Cos 0 is how much for me beta? 1. So it will be equal to how much for me? 4 times of your I. So it will be your intensity will become for me same. Clear? If the phase difference is same, the maximum intensity will be equal to that much. So take one this small question better. Try to understand. The ratio of intensities of two waves is 25 is to 1. If interference occurs, if interference occurs, then ratio of maximum and minimum intensity should be maximum and minimum intensity should be. Options are 25 is to 1, 5 is to 1, 9 is to 4, and 4 is to 9. Chota చేయండి. Ratio of intensities ఇచ్చాడు మనకు 2 is to 5. He's asking I max by I minima. So I told you the formula. I max divided by I minima will be equal to. This one is right now root 1 plus root of your I2 whole square divided by root of your I1 minus root of your I2 whole square. Root of I1 is how much for me? Root of 25 times of your I naught plus this one is root of your I naught. This one is total whole square divided by this one is root of your 25 times of your I naught minus root of your I naught into whole square. So it will be equal to your how much beta? Can anyone tell me? Root 25 is plus of your I naught plus this one. This will be equal to how much beta? How much? Yeah, 5 times of 6 times I think. So this is total I'm writing at a time. Root 25 is nothing but 5. So it is 5 I naught a plus of your I naught. So it is root 5, root of your I naught and root of your I naught. That means total will become how much for me? 6 times. So I'll write directly here. So it is root 6 times of your I naught. Clear? So it is 6 times of root of I naught divided by, this is 4 times of root of I naught. This will be whole square. Root I naught will get cancelled. 2 2s are 2 3s are. 3 square is 9, 2 square is 4. So it will be 9 is to 4. Okay? Sure. And let us try to enter our actual formula on which the problems have been based. That is about your Young's double slit experiment. Young's double slit experiment. Okay. We call it as of your YDSC. Young's double slit experiment. So what is an Young's double slit experiment, beta? What we are doing is we are taking a small slit here right now like this. Okay. And this is one small slit. And in front of this one, we are keeping a sodium lamp. Okay. So this is your sodium lamp, a monochromatic light. Okay. So light from this one will pass like this. Okay. And here again, we are keeping a double slit right now. For small openings have been present here like this. So light from this one will go in the form of your spherical wavelets in the outward directions. It will strike like this. Okay. Then from here again, from this slit, the waves will be going like this. I'm roughly drawing it better. Again, from here, they are going like this. They are interfering, you see, right? So they interfere somewhere on a screen. So screen is being kept here right now. See, these are the points where they are meeting. This point of meeting will be either the constructive interference or it may be a destructive interference, isn't it? And the point of your incidence on this one, if it is a straight line, this will be your point. This is your screen. Okay, so this is a slit S1, and here this is a small opening slit S2. Okay, so this is the basic setup of your Young's double slit experiment. Clear? So if you see it very carefully, at the center, we get a central bright point. Central bright point. Or we can say this is your white color. Okay. Am I clear? Central part will always be your white color, white light. Okay. So we are using a monochromatic source of light, the single frequency. So now if I'm talking about your white color, it will be followed down by your red color. Down there will be again, here I'm writing. Down immediately there will be your red color. Then immediately down kinda will be your green color. Okay. Then immediately below that one there will be your blue color. Like that the same pattern will also be seen on the upper part. So this will be your red, then followed by your green, then followed by your blue. You need to remember this one. Okay. Okay. Central will be the bright. Immediately there will be your dark and as well as of your bright parts. If I take an FBD for this one, free body diagram, roughly. So this is a diagram which you should remember for doing numericals. This is S1, this is S2. And here there is a screen. In the central, there will be a maximum. And from here, one source of light will be going like this and interfering somewhere here. I'm taking only about one wave bit. Okay. And if I draw a perpendicular here right now, this is a point of your intersection. So this is source S1 and distance between the two sources is D and distance between the source and screen is D, capital D. So this is your screen. S1 and S2 are nothing but a few slits. This is a rough diagram you need to remember. Central point is always right now for me what better? Dark. That means brighter point. followed by a dark, then bright, then dark, then bright. Diagram will be equal to like this. Okay. ఇట్లా ఉంటుంది రఫ్గా అంటే ఐఎమ్ డ్రాయింగ్ ద పిక్చర్ లైక్ సెంట్రల్ కార్డ్ ఏమైపోతుందంటే మాక్సిమం ఉంటుంది దాని తర్వాత తగ్గిపోతుంది తగ్గుతుంది మళ్ళీ తగ్గిపోతుంది మళ్ళీ తగ్గుతుంది మళ్ళీ తగ్గుతుంది ఫైనల్ గా జీరో అయిపోతుంది ఇట్లా బ్యాక్ సైడ్ కూడా అంతే నాన్న ఇట్లా పెరుగుతుంది మళ్ళీ తగ్గుతుంది మళ్ళీ తగ్గుతుంది ఫైనల్ గా ఇట్ విల్ బి జీరో సెంట్రల్ కార్డ్ అనే మాక్సిమం దిస్ మాక్సిమం ఈజ్ రైట్ నౌ ఫర్ మీ దాని తర్వాత ఇమీడియట్లీ ఏమైపోతుంది డార్క్ పాయింట్ వస్తుంది ఇక్కడ కూడా ఒక డార్క్ పాయింట్ వస్తుంది ఆన్ ఎదర్ సైడ్ అండ్ ఫాలోడ్ బై దిస్ వన్ ఈజ్ రైట్ నౌ ఫర్ మీ యువర్ బ్రైట్ పాయింట్ దాని తర్వాత ఇంకోటి ఇక్కడ వచ్చేసి మనకు ఫస్ట్ బ్రైట్ అవుతుంది ఇది వచ్చేసి సెంట్రల్ వన్ అండ్ ఇట్ విల్ యువర్ సెంట్రల్ బ్రైట్ అనుకుంది వైట్ పాయింట్ క్లియర్ ఉంటుంది డయాగ్రామ్ ఓకే ఇట్ విల్ నాట్ బి అ కాన్స్టెంట్ ఇట్ విల్ బి కంటిన్యూస్లీ బీయింగ్ చేంజింగ్ ఓకే now maxima minima ki conditions ఏంటి all right what do you mean by small d here small d is equals to separation between slits S1 and S2. Capital D is equals to it is the distance between slits and screen. Clear? Now maxima minima ఎలా calculate చేస్తాం నాన్న this formula is now important I'm writing a little bit darker y max will be equal to n into lambda into capital D divided by small d. This is a formula you need to remember. Maximum bright point ఎలా calculate చేస్తాము n into lambda into capital D divided by small d. Y minima ఎలా calculate చేస్తాం నాన్న y minima is equals to 2n minus 1 same again lambda capital D divided by small d. This is your y minima. Y minima అంటే dark point beta. This is your dark point. Y max means this is your bright point. ఓకే అమ్మ క్లియర్ దీంట్లో ఎన్ వాల్యూ వచ్చేసి 0 1 2 3 దీంట్లో ఎన్ వాల్యూ వచ్చేసి 1 2 3 గోన్ లైక్ అమ్మ క్లియర్
Yes, sir.
ఓకే సో బ్రైట్ పాయింట్ ఎక్కడెక్కడ ఫామ్ అవుతుంది y maxima is equals to your n into your lambda n into lambda capital D divided by small d. Lambda is wavelength, small d is the distance between S1 and S2 and capital D is the distance between your screen and as well as of your slits. Then again we'll define one important term here called as fringe width. It is the distance between two successive maxima or two successive minima. Ido maxima kada, ido ka maxima. Two successive maxima మధ్య the distance ఉంటుందో దాన్ని మనం fringe width అంటున్నాం beta. I'll write here fringe width. Represented by beta. What do you mean by fringe width? Fringe width is nothing but it is your distance between successive maxima or minima. Okay, and formula for this one is also very important. Beta is equals to lambda into capital D divided by small d. So this will be the fringe width formula. Clear beta? Sure. So formula చూసుకోండి in YDSE bright point is calculated by the formula n into lambda into capital D divided by small d, whereas y minima is being calculated by the formula 2n minus 1 into lambda into capital D divided by small d. Small n value starts from 1 2 3 for dark and small n value starts from 0 1 2 3 for your bright. This is also called as of your constructive interference. The bright point is also called as what beta? Constructive interference. And dark point is also called as of your destructive interference. Okay, na? And fringe width formula ఏముందన్న fringe width is right now for me distance between two successive maxima or successive minima. So beta is equal to lambda into capital D divided by small. So let us try to do one small numerical, get an idea. In a YDSE, write the problem beta. In a Young's double slit experiment YDSE, the fringes are formed. The fringes are formed at a distance of 1 meter, at a distance of 1 meter from double slit experiment, from your double slits of separation 0.12 mm. Okay, calculate the wavelength. Calculate the wavelength of light used. Light used. Its distance of third bright from center of screen. From center of screen is 1.5 centimeter. So first read the question carefully. Wait. I'm giving you the options. First option is 6,000 angstroms. Next one is right now for me 5,000 angstroms. Third one is your 4,000 angstroms. And fourth one is your 8,000 angstroms. So read the question first. In Young's double slit, the fringes are being formed at a distance. Fringes are being given for me at a distance of your 1 meter from the double slit. It is separation. Small d separation is given how much per meter? Small d is equals to 0.12 mm S1 and S2. So that will be equal to 0.12 into 10 to the power of minus 3 meters. Isn't it? Calculate the wavelength of the light used. Its distance of the third bright and n will be equal to 3. And third bright is it. That means y value is equals to 1.5 centimeter. That is equals to 1.5 into 10 to the power of minus 2 meters. Is asking the wavelength. So use the formula for brighter point. Y is equals to n into lambda into capital D divided by a small d. So y will be equal to how much for me? 1.5 into 10 power minus 2. N value is a third bright into lambda we need to calculate. Capital D is given how much for me better in the problem? The distance of the fringes are being formed in a YDSC. The fringes are being formed a distance of 1 meter from double slit experiment. That means capital D. Capital D is given for me as of your 1 meter. So capital D is equals to your 1 divided by small d. Small d is equals to 0.12 into 10 to the power of minus 3. Okay. Now simplify this one. See how much I'm getting the lambda. Chapter ever wavelength lambda is equals to 1.5 means this is 3 by 2 into 0.12 into 10 power minus 3. This 3 will come here right now, lambda. So this 3 will get cancelled. So it will be 2 ones 0.6. So it will be approximately 6 divided by 10. So that will be equal to into 10 power minus 3. That will be 6 into 10 power minus 4. So that will be equal to 6,000 angstroms, 10 power minus 1, 2, 3. Antena? See the calculation, but how much I'm getting? 1.5 is 3 by 2 into 10 power. This is minus 2, na beta, sorry. So this one is 3 into lambda divided by 0.12 into 10 power minus 3. This 3 will get cancelled. So this will be equal to 2 ones. This is 0.6. So 0.6 is 10 power minus 2 here. 0.2 into, this is 6 into 10 power minus 4. Minus 3, minus 1, minus 4. That is equals to lambda. So how much it is? 6 into 10 to the power of minus 6. That is your lambda. Okay. If I'm writing in terms of angstroms, the wavelength will become for me 6,000 angstroms. isn't it? So one angstrom is equal to how much Fermi? 10 power minus 10, isn't it? So approximately it will be 6,000 angstroms. First option will be the answer. Clear? Yeah, this is 0.06 liter, so it will be 0.05. 5, it will be 5, 6, 7. We use 7. Then it will come back 6,000. Yeah, I did a calculation mistake there. Done? Sure. One more question, madam. Give the next heading. Non-standard YDSC. That means if YDSC is immersed in water, then what happened to the wavelengths? Same diagram, beta. YDSC, this is your double slit experiment. This is your screen. This will be your capital D. This is S1, this is S2, and this is your small d. What you are doing is we are immersing this one into some liquid, some water. Okay. So the wavelength of light which is been incident on this one, that will change with. So wavelength will become for me lambda dash is equals to lambda divided by mu. Okay. No doubt here we'll get your central maxima, but it is slightly shift. Okay. So position of the central maxima will always remain same. So if it is immersed in the liquid, wavelength of your medium will be equal to lambda divided by refractive index of that medium. Like if it is water, you take the refractive index of water. If it is kerosene, take the refractive index of water. Then Y max will be equal to how much for me? N into this one is lambda of your medium into capital D divided by small d. That means this formula will become for me N into lambda into capital D divided by mu into your small d. This will be the formula when it is immersed in the water. We get a new term called as of your refractive index. The same way Y minima will be equal to 2n minus 1 into wavelength of that medium into capital D divided by your small d, isn't it? Let study with it. Okay. So Y of medium will become how much for me? 2n minus 1 into wavelength in air into capital D divided by 2 times of mu into T. So this will be the. So it is immersed in the water. Central position will always remain for me same. It will not change. So I'll write that one point here. Position of your central maxima will not change. Okay. But the position of first maxima, first minima may be changed. At the time, fringe width will also change. Fringe width will be equal to lambda of your medium into capital D divided by small d. So that will be equal to lambda into capital D divided by mu times of your small d. So this will be the fringe width when it is immersed in the water. Clear? Experiment. Very important. When a thin transparent when a thin transparent sheet is placed in front of one of the slit. మనం ఎప్పుడైనా 3D మూవీస్ చూడడానికి మూవీస్కి వెళ్తాం కదా, అప్పుడు వాళ్ళు స్పెక్ట్స్ ఇస్తారు, అవును కదా. ఎందుకంటే 3D మూవీస్ చేసేటప్పుడు ఒకదానిపైన ఒకటి ఓవర్లాప్ అవుతుంటుంది. అది ఓవర్లాప్ కాకుండా ఉండడానికి విల్ బి యూజింగ్ ఏ 3D లెన్సెస్, ఇదండి. సో 4D మూవీస్ 3D మూవీస్ చూడడానికి స్పెక్ట్స్ సిస్టమ్ చూడండి, దట్ విల్ బి ఓవర్లాపింగ్. దాన్ని మనం థిన్ ట్రాన్స్పరెంట్ షీట్ అంటాం. అలాంటి షీట్స్ కనుక మనం ఐడియాస్ లోపల పెట్టామనుకోండి, లైక్ దిస్. ఇది మన స్క్రీన్, ఇది క్యాపిటల్ డి, ఇది స్మాల్ డి, and this is S1 and this is S2. ఇక్కడ నుంచి one ray is going here interfering, one other ray is going and here it is interfering. This will be your central maxima and this will be equal to your central part. Okay, సో ఇక్కడ మనము ఒక థిన్ ట్రాన్స్పరెంట్ షీట్ పెట్టామనుకోండి, దీని థిక్నెస్ టీ, రిఫ్రాక్టివ్ ఇండెక్స్ వచ్చేసి మీ. ఓకే, సో అప్పుడు పాత్ డిఫరెన్స్ ఎంత అవుతుంది రైట్ నౌ ఫర్ మీ బెటా? Path difference delta x will be equal to your mu minus 1 into t will be the path difference. Okay, so central maxima ఏమవుతుంది, షిఫ్ట్ అవుతుంది. ఇక్కడ central maxima will try to shift somewhere away right now. ఇంతకు ముందు ఇక్కడ ఉండేది, now central maxima will be equal to here. Okay, so I'll write that one. Central maxima will shift in the direction in which slab is introduced. ఎక్కడైతే స్లాబ్ పెడతామో ఆ సైడ్ లో సెంట్రల్ మాక్సిమా అనేది షిఫ్ట్ అవుతుంది. ఓకే, ఫ్రింజ్ విడ్త్ విల్ నాట్ చేంజ్ పెట్టదు ఇందులో. Fringe width will not change. Okay, that is important thing you need to remember. Central maxima will shift in the direction of the slab. And path difference is given by the formula mu minus 1 into your t. So phase difference will be equal to how much better for this one? I'll write all the formulas here. Path difference delta x is equals to mu minus 1 into thickness of the slab. Number 2, phase difference that is delta phi is equals to 2 pi by lambda into delta x, isn't it? This value will be equal to how much? Delta phi is equals to mu minus 1 into thickness t into your 2 pi, isn't it? So I'll write here right now. This is your 2 pi by lambda into mu minus 1 into thickness t. This will be the path difference. Okay, now what will be the number of fringes displaced? But any displays any. So number of fringes displayed, అంటే ఎన్ని పైకి వెళ్ళింది, that will be equal to mu minus 1 into t divided by lambda. Okay, so number of your fringes shifted will be equal to mu minus 1 into thickness t divided by your wavelength of the light used. Now what is the distance of shifted fringes beta from the central maxima? Distance of shifted fringes అంటే సెంట్రల్ మాక్సిమం నుంచి ఎంత షిఫ్ట్ అయింది, fringes from central fringe ఓకేనా? అంటే ఇది ఈ డయాగ్రామ్ చూడండి. ఇక్కడ నుంచి సెంట్రల్ మాక్సిమం నుంచి షిఫ్ట్ అయింది కదా, ఇది ఎంత షిఫ్ట్ అయింది ఎక్స్. సో దట్ వాల్యూ యూ కెన్ క్యాలిక్యులేట్ బై ద ఫార్ములా ఎక్స్ ఇస్ ఈక్వల్స్ టు d into mu minus 1 into thickness t divided by your small d. Okay, shift of your central maximum. This is your shift of central maximum. Okay, so number of fringes shifted will be mu minus 1 into t divided by lambda. Clear, beta? So these are the some of the formulas you need to remember in your YDSC, which should be always on your tip. Now take your PYQ booklets and try to complete all the MSET questions only on your YDSC. YDSC ఒకటి complete చేయండి, and tomorrow session of a class will try to complete with your diffraction and as well as of your polarization. చాలా ఇంపార్టెంట్ అండి, ఒకటి రెండు సార్లు చూడకుండా రాయాలి, దెన్ ఓన్లీ యూ కెన్ డూ దిస్ ప్రాబ్లమ్. ఇది వచ్చేసి when it is air లో ఉన్నప్పుడు దిస్ ఆర్ ది ఫార్ములాస్. Okay.